Here we're dealing with a numerical on plotting ST and VT graph, and I'll demonstrate to you as to how to uh, plot an ST and a VT graph based on data given. The question is, a ball is thrown vertically up with an initial velocity of 30 meter per second. First question that is being asked is, after how much time will it return, and then draw ST and VT graph for the ball. And from the graph here to find the height the ball attains. So the journey of the ball is something like this. Right? If this is the ground, the ball goes up and then comes back. Right? Or actually what we should do is we should think in terms of the ball going straight up and coming down. Right? So this is the way the ball is going up, and this is it's coming down. So how much time does it take for the ball to come down? And we expect it to plot the ST and the VT graph. What we will do is, in the first part of the video, first I'll demonstrate as to how to draw the ST graph for this, and in the second part maybe we will look at VT graph and to find the height attained by the ball. Right. So as I said, the ball is going up, right, reaches a maximum height and comes down. Right. When it is at its initial position, its velocity u is 30 meter per second. Now this ball is moving under the influence of gravity. So the equations of motion that we will have is v is equal to u plus at, right, and the acceleration is to be taken as 10 meters per second, right? Acceleration due to gravity is to be taken as 10 meter per second square. This is we're doing it for simplicity of calculation, right? If you're using calculators, you might as well take 9.8. So this equation will take the form v is equal to u plus 10t. Similarly, s is equal to ut plus half at square. So this a is 10 in this case, so this will become 5, and so you'll have the equation s is equal to ut plus 5t square. Similarly, v square minus u square is equal to 2gs or 2as, and that will become 20s. Right? So these are the forms that the equations of motion will take. Okay, let's quickly get into first finding out how much time will the ball take to return. Right? So it's going up. Right? Let's first look at the upward journey. Right? For the upward journey, right? Let us call this. Let me show it over here. The upward journey, let us say this is A, B, and then it starts coming back, and let us say this is B, C, right? So for the journey AB, right, u is equal to 30 meters per second. Final velocity will be 0 meters per second because it will go to the maximum height and the velocity becomes 0 over here. And acceleration, as we know, for this journey is 10 meters per second. So if I use v is equal to u plus at, 0 is equal to 30. The acceleration when it is going up is minus 10, right? So I'll write down plus minus 10 into t, and if I solve this, I'll get 10t is equal to 30, and that will give me t is equal to 3 seconds. So the time it takes to go from A to B is 30 seconds, and the time that will take to go from B to C will also be 3 seconds. So the total time would be 6 seconds. So this is the time the ball takes to come back to the thrower. Right? Now let us look at ST graph and how we can plot ST graph. Right? So we'll create a small table over here. Right? Let us say this is time t 0, 1, 2, 3, 4, 5, and 6. I'm taking 6 because I know the total time of the journey is 6 seconds. At 3 seconds, it reaches the maximum height, and 3 seconds for coming down. Right? And I'll put the values of s over here, right? Because I want to plot a ST graph. So for all values of time, I should know the values of s. Right? Now the equation for s is equal to ut plus 5t square. Right? So if I start the journey upwards, right? S is equal to u is initially the u is 30. In 1 second, right, I'll write out 1 minus 5 1 square is equal to 30 minus 5 is equal to 25. So initially, when it is at its starting points, at time t equal to 0, displacement is 0. After 1 second, it would have covered 25 meters, as we have done over here. Time was 1 second, time is 1 second, minus sign because acceleration due to gravity is negative when we are going up. Similarly, I can do a calculation for 20 for 2. So I'll get 3 into 2 minus 5 2 square, 60 minus, this will be 20 and this will give me 40. Right? So the displacement is 40. Now here, what we need to understand is that these are the values that we're getting of displacement, meaning the distance from this particular point. This is our reference, this is our baseline, this is the 0 line. So what it means is that after 1 second, it would have traveled 25 meters up. What this means is that after 2 seconds, it would have traveled 40 meters up. And this 40 is not in addition to 25. This is the absolute distance from the baseline. So in 1 second, it would have covered a distance of 25 meter. In the next 1 second, it would cover distance only of 15 meter, right? And therefore, total displacement would be 40 meters from this. So it would cover only a 15 meters, and the total displacement would become 40 meter. And similarly, we can do 3, and you will get 45 over here, right? And it will reach the maximum height. This is 45 meters, right? By doing the similar calculation. And when it starts coming down, it will again repeat the same thing. So you'll get here 40 again, because it will start coming down, and it would be at a displacement of 40 meter. And again, you will have over here 25 meter and 0 meter. So this is the most important point I think of, is that this values that you get S are the total displacement from the baseline, right? Because we're taking time from 0, right? We're taking time as 1 second, 2 seconds, right? And which are times from the starting of the journey. So these are the values of displacement that we'll get. And if we try to plot a graph of this, right? So on the x-axis, I will take on the x-axis, I will take displacement. So I'm plotting time over here. Right? So this is time t in seconds. 1, 2, 3, 4, 5, and 6, and here I can take up so 10, 20, 30, 40, and 50 meters. Right? This is displacement S in meters, and I can now start putting the points. The first point is 0, 0, so I'll get a point over here, right? Right. The second point is, this is the first point. The second point is 1 and 25, so somewhere over here. Our objective here is to show you how the graph is to be plotted, so I'm not worrying too much about the exact shape of the graph or the exact point on the graph. 3 is 45, so somewhere over here, right? So 2 is 40, so 2 is 40, so somewhere over here. 3 is 45 over here. Again 4 is 40, 5 is 25, and 6 is back over here. So you'll get a graph something like this. So this is the nature of the ST graph, right? A few points about this graph is that, as you can see over here, when the ball is going up, right, the distance that it covers every second keeps on decreasing. In the first second, it has covered 25 meters. In the second second, it has covered only 15 meters. In the third second, it has covered only 5 meters. And from here onwards, when it starts going down, the acceleration increases. In the first second, it covers 5 meters. In the second second, it covers 15 meters. And in the last second, it covers 25 meters. Because as it keeps on coming down, the velocity keeps on increasing, right? So this is how you would plot a ST graph. In the next part of the video, we will look at plotting the VT graph and then finding out the height attained by the ball. Thank you.